1 second. And there we go. Okay, perfect. So once again, good morning, everybody. Hope you're all doing pretty well. So before we get into any of the math stuff today, just a couple of really quick things. So firstly, today is our first office hours. So office hours running today from 4:15 to 5:15. Generally speaking, I am home by 4:15 and I should be able to log on and be in the meeting by 4:15. But if I'm a little, if I'm a couple minutes late, just stay in the call. I promise I will be there. So if you get there before me, just, chill out for a couple minutes and I promise I'll be there as soon as I can. Okay. So yeah, office hours today, and then going forward, next week, well, actually, I guess next week's a little bit of a exception because of Labor Day, but all weeks moving forward beyond next week, we'll have office hours on Monday and Wednesday. Okay. So this week, again, first office hours next week, and I'll remind everybody, next week we're only going to have office hours on Wednesday again because of Labor Day, and then for the weeks that come afterwards, Monday and Wednesday will be the regular schedule. Okay. Another quick reminder, and this is the only reminder that I'm going to give about this moving forward. Your first quiz will be this Friday. So please make sure that if you needed to speak to me about something that you aren't understanding, totally fine. If you wanted to, set up a meeting with me that outside of office hours, it's a little late in the week, but we can still maybe try to do something. And please make sure you have your OneDrive situations figured out if you are having trouble with that. Okay. Alrighty. And next thing, so I sent out an email last night at some point, and the email was just in regards to a mistake in the lecture. So I said that in the email, if you catch a mistake that I make, be it in the lecture videos, in class, whatever the case may be, I'll just add a point onto your onto one of your quizzes, right? So there was actually a second mistake in the lecture. So the first mistake I pointed out, I said that I accidentally incremented a number from 4 to 5, and then that mistake just carried through. The second mistake happened around the 26-minute mark. So let me explain what was going on in the lecture at that point. So I was describing the expanding of cubes at this point. So we had a plus b cubed, and I said it comes out to be a cubed plus 3ab squared. And then this should be a 3a squared b. And lastly, I believe I put a minus b squared, right? This right here was the issue. The problem would be that this should have been a cube, not a square. So in the lecture, I didn't address this. Now, I've had students bring this up to me before. The reason that I left it out is because I wanted to purposely give you all a chance to see if you could actually, find the mistake yourselves. A couple of you actually did. You sent me emails. Since those of you who, found it, congratulations, you got that extra point. And then again, moving forward for everybody else, this is just the policy, right? So if you find an error with what I'm doing, that's absolutely fine. Just, let me know that there's an issue. And then if you're right, great, you get a point for it. Kendra, would you please post the lectures before the quiz? So the lectures are getting posted. Are you talking about the our class meetings? Just want to verify. Okay, so I only post the particular class meetings, ones that people have specifically requested. That was what we discussed on syllabus day. So if you have a particular one, sure. I wasn't planning on posting every single class meeting unless again somebody wanted every single one. If that's the case, if you're gonna watch every one, that's totally fine, and I can do that. Or not you in particular, anybody for that matter. But if you want particular ones, that's far easier to accomplish. So let me know. Either way, I can do both. I can post all of them, or I can just post individual ones, whatever's best for you all. Okay. Okay. So that was all I had for the mistakes. So again, that's the policy moving forward. For all of them, Kendra? Okay, sure. Yeah, I can definitely do that. That's fine. Okay. So the next thing that I wanted to touch on. So we were talking in this lecture about expanding polynomials, multiplying polynomials, so on and so forth, right? And one thing that we got to was a binomial times a trinomial, or two terms in a parenthesis times three terms in parentheses, right? So that we saw something like this, where we had a plus b times a squared minus, oops, sorry, not a two, minus ab plus b squared. And this should have come out to be a cubed plus b cubed, and this is known as the sum of cubes formula, right? And I definitely mentioned this in the lecture, but what I didn't do, and I remember kicking myself after I recorded this lecture the first time, is I didn't bring up the acronym that was really useful in remembering this. So there was an acronym that I brought up originally when we were expanding binomials, so two terms times two terms, and that was FOIL, right? FOIL stands for first, outside, inside, last. And that's, how it can help you remember how to distribute every single term. Well, there's actually a nice little acronym for this as well. And the acronym is SOAP. So I'll write that down here as well. So what SOAP helps you figure out is it helps you remember the signs of everything. So by the signs, I'm talking about, the plus here, we have a minus here, we have a plus here, right? And what SOAP actually stands for is same, opposite, always positive, right? So what am I referring to here? Well, let's say you were given this a cubed plus b cubed. And we wanted to backtrack a little bit. We wanted to get to the other side of the equal sign. Well, what SOAP allows you to do is it helps you figure out what the signs should be when you break this down, when you decompose it, right? So same, again, this is referring to this plus here. So we have addition going on between the a cubed and the b cubed, and that's what's going to correspond to this plus right here in our binomial, this a plus b. So the first sign is always going to be the same as whatever's going on between the cubes. Then we have opposite, right? So if this is a plus, then the next sign that should happen should be opposite of it, which is a negative. And then finally, the last sign, which is generally in front of the b squared, is always going to be positive. So that's what that AP stands for, okay? So again, FOIL, SOAP, these are just mnemonic devices to help you remember, the little attributes, try to help you, keep track of what's going on. If it is helpful for you, great. If you can remember it without it, also great. Okay. I just wanted to bring it up because I remember that I, didn't bring it up in the lecture, so I figured now would be a good time. Okay. So let's do a quick example just in regards to SOAP, and then we can, kind of move on from there into some other examples that touch on the stuff in the lecture. So let's say we had x plus 3, and this is being multiplied against x squared minus 3x plus 9. Okay, so if I told you to expand this, well, the way that we expand this is we take our binomial and we kind of chop it up, right? We take the first piece of the binomial and multiply it against everything that's in the trinomial, and then we take the second piece of the binomial and do the same exact thing, right? So what is this going to look like? Well, this is going to look like, when we break it down, x, which is, again, the first term of the binomial, times x squared minus 3x plus 9. And this is going to be added to, and we know it's going to be added because we keep the sign that was in front of the 3, right? So it's still plus 3 times, and the exact same trinomial again, right? So x squared minus 3x plus 9. And now what we can do is we can go and start doing this multiplication. So you take your x and you multiply it throughout everything in the trinomial, right? So multiplying throughout, x times x squared, of course, gives us an x cubed. X times a negative 3x gives us a negative 3x squared. And x times a positive 9 is a 9x. We can do the same with this positive 3. So we have positive 3 times x squared, which gives us a plus 3x squared. Positive 3 times a negative 3x. So we multiply the coefficients. We should get a minus 9x. And then 3 times 9, they're both positive. We end up with a plus 27, right? And we see we can actually condense this a little bit. Things are going to start crossing out here, right? So we have this term right here, this negative 3x squared, and this positive 3x squared. So these are going to go away. We see we have a positive 9x and a negative 9x. So those are also going to go away. And so all we have left when everything cancels out is x cubed plus 27. And now why am I bringing this up, or why am I showing you this? Well, if we look at this, remember the form that we had to have this in, right? The form that we had to have this in, if we could immediately jump to it saying that it's sum of cubes, well, we wanted it to be in the form of a plus b, and then a squared minus ab plus b squared, right? And we know that this is the formula for sum of cubes, just like we just talked about. So in theory, this should always come out to be a cubed plus b cubed, right? And now we start identifying, okay, so what would be a here? What would be b here, right? And we can see a direct correspondence, right? In this case, a would be x, right? That would be our unknown. B would be 3. And we see that, oh yeah, it actually works out this entire time, right? We see that we have this a squared here. That would be our x squared. We have this minus sign, same here as we do there. And although it's written as AB, we know that multiplication is associative, right? Which means that, commutative, which means that we can, move things back and forth. So AB is the same thing as B times A. So we have this 3, which was our B. We have our X, which is our A. So we see that we do, in fact, have that term. And lastly, we do have that B squared, right? Our 3 times 3, or 3 squared. And that's, of course, 9. So in theory, we should end up with a cubed plus b cubed. And remember, our a is x, so we should end up with an x cubed. And our b was 3, so we should end up with a 3 cubed. And what is 3 cubed? Well, 3 cubed is 3 times 3 times 3, which is 27. And so we would end up with x cubed plus 27. And in fact, that's exactly what we ended up by doing it the long way, right? So the point that I'm showing here is if you can see the blueprint in the values that I give you, or the values that are presented in front of you, you can just immediately make this jump here, and it can save you a lot of time. There's a little bit of memorization that's involved in it, but at the very least, again, it's worth it because it can save you the hassle of multiplying everything out, doing all the cancellations, and then ending up here. Does anybody have any questions on this before we move forward? Okay, great. So I'm going to go ahead and clear this off, and let's get into some other examples. Okay, so again, this lecture was basically focused on polynomials and how to handle polynomials interacting with one another. We looked at polynomial addition, subtraction, and multiplication, right? When we see the word expand, that really just means like multiply everywhere, like distribute, right? So that's just a form of multiplication. The only thing that we really didn't talk about just yet is polynomial division, and that's going to come later in the course. So for right now, we're just focusing on addition, subtraction, and multiplication. So let's take a look at an example here as far as polynomial subtraction or combination and see what's going on. So let's say we have the following: negative 5x to the 4th minus 2x squared plus 3. And we're going to subtract from it. Hopefully I can get this all on the same screen here. We're going to subtract from it a negative. That looked like a 2. Let me redo that. There we go. Negative 3x cubed plus 4x squared minus 6. Okay. So in the lecture, the way that I originally did it was I said, kind of do matching, like you're looking for like terms. So you're looking for things that essentially have the same variable and the same exponent, right? That's what it means to be a like term. And then you would just do the matching and set it up that way. If it's easier for you to see, you can also set this up in columns. So what I mean by columns is, okay, so we see that we have a negative 5x to the fourth. We can put this over here, right? So negative 5x to the fourth. We're going to leave a blank space because there's no x cubed, right? We see that it jumps immediately from x to the fourth to x squared. So I'm just going to leave a space here and just move down. So we have a negative 2x squared, and I'm going to leave another space because we don't have an x to the first, right? It just jumps right to the constant. So we're going to leave another space and put a plus 3. Okay, we know where the operation is subtraction, right, as indicative of the subtraction going on between them. And so we can again do this where we set this up in columns. And now notice that the highest exponent that we have, highest degree, is an x cubed, right? So if I'm setting this up in columns, I'm just putting this in between, right? Because it's subtracting against its like term, but there is no other x cubed that it's subtracting from, right? It's essentially 0x cubed, which we can put a placeholder here as 0x cubed. We can also move on, right? So we know that we're adding 4x squared, and we have this minus 6 here all the way at the end. Now, if there were an x in here, in this second expression that we have, then I would have put this, plus x right here in its own column. I would have put a placeholder up here, right, where there's 0 x's. I'm not sure what my pen is doubling. I apologize. There we go. Where there's 0 x's, and then you can proceed with the subtraction this way, right? Okay, so just doing it just in the columns way, just so we can actually see this. Again, I'm just gonna break this up so it's a little more visible. There we go. Okay, so we have negative 5x to the fourth, and we're subtracting nothing from it, right? We can put a placeholder here, 0x to the fourth, nothing's being subtracted from it. So it's still just going to stay as negative 5x to the fourth. So that's the first part of our solution. Okay, so what's coming next? Somebody help me out. We have this 0x cubed, right? What are we taking away from it?
It'll stay the same.
Okay, so be careful, right? So we know that the operation going on is subtraction, right? We're subtracting this entire term from this entire expression from the first expression, the trinomial from the first trinomial. So we have to apply this negative sign to every single term, right? So if we're subtracting a negative 3x from essentially 0 from nothing, well, that's what that's going to look like is, again, 0 minus a negative 3, right? And so we know that this, when we have double negatives, it's essentially addition. So this is really the same thing as 0 plus 3, right? And we just have to tag on the fact that we're dealing with x cubes here. So it's really 0x cubed minus a negative 3x cubed. Again, the same thing as saying 0x cubed plus 3x cubed. So we just end up with positive 3x cubed. Yeah, exactly, Kendra. So we know it's going to be addition. So we end up with a positive 3x cubed there. Okay, somebody help me out with the next column, please. We're dealing with our x squareds now. Carolina?
Negative 6x squared.
Negative 6x squared. Yeah, exactly, right? So we have an already negative number, right? We have negative 2x squared. And what we're going to do is, even though this is a plus here, remember, we have to apply this negative sign to it. So it's really negative 2x squared minus 4x squared. And so that's going to give us a negative 6x squared. Perfect. And then the last step here, we have this 3 minus a negative 6. 3 minus a negative 6 is the same way as saying 3 plus 6. And so, of course, that's going to give us a positive 9. And so we end up with negative 5x to the fourth plus 3x cubed minus 6x squared plus 9. And that would be our final solution here. So the point that I just wanted to say is, if it's easier for you to set it up in columns to where you can see it like this, that's totally fine. It works out the same way. It's just a different, visual representation. If it helps for you to do the matching thing and put them together in parentheses, that's also totally fine, right? You can definitely do that. Whatever makes sense to you in your head when you're doing the work. Either way, comes out to give you the same answer. Okay? Any questions on this before we move forward? Okay, cool. Let's go ahead and keep on rolling then. Okay, so that was polynomial subtraction. Again, very similar as polynomial addition. The only difference is the operation that you're doing. Let's take a look at some polynomial multiplication instead. Let's say I have 2 times n minus 3 times n plus 4. Okay, who can help me out with this? What am I going to be doing here as far as trying to handle these two binomials being multiplied against each other? Denny?
To do the FOIL operation, you share the 2 with the n, and then with the 3, and then with the whole thing. Like 2 times n will be 2n.
Okay, so what you want to do first, Denny, is you want to distribute the 2 into everything?
Yes.
Okay, cool. So if we do it that way, what we're going to end up with here is we're going to have 2n minus 6, right? And we got here because 2 times n is, of course, 2n. 2 times negative 3 is negative 6. So we have 2n minus 6, and we have this n plus 4 entirely untouched, right? We haven't done anything with that. So now, Abby, I saw your hand go up. Help me FOIL this if you can. So FOIL stands for stuff, right? So what's going to be the initial thing that we do here?
So you're gonna distribute the 2n to the n.
Okay, great. And so what's that going to give us?
2n squared.
Perfect. So we did first. Okay, what's outside?
The 2n to the multiplied to the 4.
Perfect. Okay, so we have 2n times 4, and what should that give us?
8n.
Great. Okay, now we have inside.
So negative 6 times n.
Perfect. So minus 6n. Great. And then last but not least, and I'll do this one for you, we have negative 6 plus 4. So that's going to give us a negative number, right? Because we have negative times positive. And so that should give us a negative 24 here. Okay, and now what we can do is we can go ahead and condense the middle, because 8n minus 6n, we see that they are like terms, right? It's the same variable to the same power. They're both to the first power, so we can condense those. So we have 2n squared plus 2n minus 24. And this would be our final answer. Now, I want to go back, and I want to do this again, but slightly differently. So the way that we approach this initially is we multiplied, or we distributed the 2 to the first term, right? We multiplied the 2 times the n, the 2 times the negative 3, and that's how we got the term 2n minus 6. So what I want to do is, instead of doing it in that order, I want to do it in the opposite order, right? So I want to multiply the n minus 3 times the n plus 4 first, and then take care of the 2 afterwards. So I'm just going to write this again. So we have 2 times n minus 3, and this is also multiplied against n plus 4. And what I'm going to do here is, again, I'm going to take care of this multiplication first. So what that's going to look like is, again, we're going to handle FOIL. So we're going to have the first terms being multiplied first. So that's going to be n times n, which gives us an n squared. And remember, this 2 is just hanging out, outside of everything, outside of all the parentheses, and it's going to be multiplied against everything when we're all done. So we keep that 2 dropping down with every step. So we have 2 times n squared. Now we have outside, so that's going to be n times positive 4. So we have 4n. We have inside, so minus 3n. And then lastly, we have negative 3 times positive 4, which gives us a negative 12. We can clean this up a little bit. So cleaning this up, we have 2 times n squared. And by clean it up, I mean we can look for the like terms. We have a positive 4n minus 3n. So of course, this is just going to give us a plus 1n or plus n. We know we can omit that 1. And we have that minus 12. And now what we can do is we can take care of that last step of multiplying the 2 throughout. And so what that's going to look like is, again, you take your 2 and you distribute it to every single term. So we have 2n squared plus 2n minus 24. And it looks exactly like what we had the first time, right? the point I wanted to show here is, again, we learned that multiplication is associative, which means that if we have three things being multiplied, right, A times B times C, it doesn't matter if you do the first two things multiplied against each other first, or if you do the last two things multiplied against each other first, right? You can multiply A and B together and then take whatever that product is and multiply it against C, or you can multiply B and C together and then multiply it against A when you're done, right? And that's exactly what we kind of showed here, that it doesn't matter what order you multiply in, you should get the same answer either way. Now, sometimes there can be cases that you come across where doing one multiplication might substantially make the problem easier. You might reduce values, you might get numbers a lot easier to work with, or you might clear fractions in doing so, and then that can make your life a lot easier. So always be on the lookout for things to make your life easy, especially when you can use rules like associativity to do so, okay? Any questions on how to distribute, how we did FOIL or anything? I also do just want to note, just really quickly, I'm just going to write this one more time without the 2. So if we had n minus 3 and n plus 4, we did this again using FOIL, but you don't necessarily have to use the acronym here, as long as you just make sure to distribute everything, right? What the acronym accomplishes is it reminds you to do all of the distributions. So essentially, in the order that it's given in, you're doing first, outside, inside, last, right? But you can do that multiplication in any order and it'll come out to be the same answer, right? So you could do, first, outside, inside, last, or you could totally do it in the exact opposite order, right? You could do the last, you could do the inside, you could do the outside, and then you can do, first afterwards, right? So the point that I'm making here is that however you remember it, totally fine to do as long as you make sure you get all of the distributions. Okay. Alrighty, let's go ahead and move on to the next example here. Okay, so let's say we have the following. Let's say we have y minus 6 times y plus 6. Okay, before we even try to do this, this has a special name. Does anybody recognize what this is an example of? So take notice of the fact that these two expressions are almost identical, except for the fact that one's a minus and one's a plus, right? It's the same variable y, it's the same value 6, it's just a minus 6 or a positive 6. Anybody remember? Denny?
The community property of multiplication?
Nope, so this isn't a property. This has a special name as far as the distribution is concerned. Carolina, you want to give it a shot?
Difference of squares.
Difference of squares, yeah. So when we're talking about the blueprints, right? Difference of squares is one that's very, very, very important. It's gonna, rear its head quite often in this course. So please make sure you remember this, right? Difference of squares is in the form a plus b times a minus b, and this should give you always a squared minus b squared, okay? Now, and I'm realizing that looked like a 1, my apologies, a squared minus b squared. And the reason it's called difference of squares, remember, is because there are squares and a difference, right? It's the difference between the squares, difference of squares. So what you have to remember for this to work, for you to remember what difference of squares is that you have to remember that it's the same term being multiplied basically against itself, with the only difference being the signs, right? So we have y minus 6 times y plus 6. So if we look at our blueprint, we should just end up with those two values squared with, separated by a subtraction. So we should, in theory, end up with y squared minus 6 squared. And of course, 6 squared we know is 36, right? Let's go ahead and FOIL it just to make sure that this is in fact what we get. So foiling this, again, first, outside, inside, last. So doing first means doing y times y. We end up with y squared. Doing outside, we have y times a positive 6. So this is plus 6y. Now we do the inside. So this is negative 6 times y. So we have a minus 6y. And then we have last, which is negative 6 times positive 6. And negative times positive gives you a negative. So we know that this should be a negative 36. And what we see happens is the positive 6y cancels with the negative 6y. We end up with y squared minus 36, exactly like we hypothesized when we looked at the blueprint of what we should get when we recognize that this is in fact difference of squares. So again, this is one of those things that as soon as you get in the habit of seeing it, once it starts clicking for you, you can just say, oh, this is difference of squares. Great. You know how to, you know exactly what the answer should be based off of the values that A and B are, or what they're given to you. Conversely, when we start getting into factoring, once you start, getting the habit of noticing the something squared minus something else squared, you know exactly how to factor it and how to break it up. Okay, so I think factoring is the next lecture that's coming up today, I'm pretty sure. So, this will definitely come back around. But again, just give it some time. Try to remember difference of squares and the other, common blueprints for things that we run into in this course, or basically everywhere. And hopefully this will start clicking. Okay, so any questions on this, on difference of squares, or showing the fact that, FOIL really does lead to the same answer? Okay, great. So let me go ahead and clear this. Okay, so what homework questions do you all have for me? Denny, do you have a question?
Yeah, I do. Before we get to the homework, and I'm sorry, I thought my hands was raised when you asked for if we have any questions.
Sure.
So when it gets for us to take a quiz, will you like us to do the way that you do, like the easy way, just put it in the answer, or would you like us like to give you like the FOIL and like solve it before we give you an actual answer?
So in the beginning, definitely with these first quizzes, I want to see all of the work. Basically every step that you would normally take, I want to see all of those steps written out. As we get further and further into the course, you'll start to have, these steps that you necessarily don't have to take. So for example, by the midterm, if I did give you, y squared minus 36, and I said factor this, you could immediately just jump into, y plus 6, y minus 6, and I would be totally fine with this because, it shows that you understand this is in fact difference of squares, right? But for the beginning, I do want to see all the steps that you're taking. So show me all the addition, show me all the subtraction, the multiplication, and that's going to count for way, way more than giving me the correct answer. Again, just to reiterate, if a question on the quiz is worth 3 points and you only give me the correct answer, you're only getting 1 point. So please make sure you show me your work. Okay, good question. Would you be able to post this lecture? Yes. So I believe Kendra asked for all the lectures to be posted. So I will go ahead and I'll start posting them probably today. If I don't get to it today, then definitely tomorrow. Abby, do you have a question?
Can you go over question 55, the one with the fraction in it?
Okay, sure. So we'll get to homework questions in just 1 second. Let me just answer Helen's question, and Jacqueline has her hand up, and then we'll get to homework, okay? So Helen, is the quiz only 1 question? No, quizzes generally are 3 questions long. You generally have about 25 minutes to do it. And the only exception that I can think of is there's 1 quiz later on where it's only 2 questions, but there's a couple parts to it. So 2 to 3 questions depending on the quiz. Okay. And Jacqueline, do you have a question before we move forward?
Yeah, I was gonna ask if you could go over 69 just because you emailed me earlier about it and you said you would discuss it in class.
Yep, no problem. Okay, so again, guys, first quiz is this week. Okay, so definitely talked about this already at the beginning. First quiz is happening this Friday. Okay, so let's go ahead and jump into the homework questions, and then we'll circle back to any other questions that you may have regarding, the course or the quizzes or whatnot. Okay, alrighty. So Abby, correct me if I'm wrong. You said 55, is that right?
Yeah.
Okay, great. So we can start there. That's totally fine. Okay, so starting with 55, let's take a look. So question 55, we have x plus 3 over 4 quantity squared. So the question says expand. Expand really just means multiply or distribute, right? We're taking this this binomial that's being squared, and we want to, turn it into its each individual component. We want to, break it up via multiplication. So first things first, what does this exponent indicate? What does an exponent mean? Like if we have something squared, what is the operation that we're really doing? Any takers? Caroline?
Multiplication.
Multiplication, right? But it's multiplication of what? So how can I turn this into something that we can actually work with? So remember, exponent is essentially saying whatever's under the exponent, we're taking that entire unit and we're multiplying it against itself the number of times that the exponent shows, right? So if the exponent is a 2, which it is in this case, we're taking whatever is under the exponent and we're multiplying against itself twice. So in this case, we have x plus 3 over 4 quantity squared. Well, that's going to tell us that we're going to take x plus 3 over 4, and we're going to multiply it against itself twice, right? So we have once, and we're going to multiply it against itself again, x plus 3 over 4. Okay, and that's your first step, right? So the first step is really just understanding what the exponent is doing and how we can, kind of translate it from an exponent into something that we can now work with. Okay, so we have a binomial times a binomial, 2 terms times 2 terms. What should we do here? Denny.
I'm gonna say that I don't know if I did it correct because I also have questions. But then what I did was that I did x I distribute I foil. So x times x is x squared, and then the inside with the inside and the outside with the outside.
Yep. So what we're going to do here is we're going to FOIL, right? We have a binomial times a binomial. It doesn't matter that one of them is a fraction. It could be quite literally anything in there. When you have a binomial times a binomial, you're going to want to make sure that you distribute. And the way that we learned how to do that is by FOILing. So just like Denny said, we're going to take first term, right? So that's going to be first in each of the parentheses. So x times x. And this gives us an x squared. Next up, we have outside. So we have x times this positive 3/4 over here. So that's going to give us a 3/4 x. We have inside. So that's going to be positive 3/4 times x. So we have another instance of 3/4 x. And then we have last. And last is going to be 3/4 times 3/4. And what that's going to look like, and we can even write this here just so we can, see it. So just rewriting everything, 3/4 x plus 3/4 x. And again, the way that we handle fraction multiplication is we multiply straight across, right? We multiply numerators, we multiply denominators, and hopefully we get the right answer, right? So 3 times 3 in the numerator gives us a 9. In the denominator, 4 times 4 gives us a 16. And so now we've taken care of the fraction multiplication. And all we have left to do is to look for like terms so that way we can hopefully condense, right? So if we're looking for like terms, remember you're looking for the same instance of the variable at the same power, right? So there's nothing that we can condense with x squared because there's no other x squareds. We can't do anything with the 9/16 because there's no other constant. There's no other just, a pure number that we can add to 9/16. But we see that we have 3/4 x and we have another 3/4 x. So we can actually combine those two. And when we combine those two, keep in mind, we're not touching this x squared. We're not touching this 9/16. We're just adding 3/4 plus 3/4. And what that should give us is a 6/4 x. Remember, fraction addition is just adding straight the numerators, your denominator stays the same. And the very last step, and this is one that I am expecting of you guys, is you do need to make sure that you properly reduce your fractions, right? So if you end up with a 6/4 here, you're not quite done. The last thing that you have to do is you have to reduce this into a 3/2 x. And then, of course, we have this 9/16 hanging around the end. Okay, so just to reiterate the steps that we took, we first started with x plus 3/4 quantity squared. The exponent let us know that we're taking that entire entity and multiplying against itself, right? And because it's a square, we only have to do, just those two terms multiplied against itself. We do FOIL, or we, do our distribution. We ended up with x squared plus 3/4 x plus another 3/4 x, and then our 9/16 as our constant. We added our like terms. We got our 6/4x, and then we realized we could reduce that into 3/2 x, and then this would, of course, be our final answer. Okay, any questions on this one? Okay, so I also just want to show that we could do this without foiling. We can do this entirely without foiling. The reason we can do it without foiling is, remember, we learned one of our common, again, I keep referring to them as blueprints because realistically, you can plug in any value as long as it's in that form, and it'll always spit you out, the correct answer, right? We learned a blueprint for when we have a binomial being squared. And so this is A plus B quantity squared. Does anybody remember what this should come out to look like? Just the blueprint itself? Helen?
Is it a squared plus 2ab plus b squared?
Perfect. A squared plus 2ab plus b squared. And remember, the only difference between a plus b quantity squared and a minus b quantity squared is the sign, right? So the sign of the 2ab is always going to fall directly from what's going on between the a and the b that's, underneath that exponent, right? So if that were a minus b quantity squared, then the 2ab would be negative, okay? So we have this blueprint, a plus b quantity squared, and we know it should always fall out as a squared plus 2ab plus b squared. Well, if we look at this, we see we do have that, right? Our a, again, is our x, and our b is our 3/4, right? So what we can do is we can actually go ahead, and if we plugged in our numbers, which I'll do over on this side, we should end up with x squared. Remember, that would be our a squared term right here, plus 2ab, so plus 2 times a, which is, of course, x, times b, which in this case is going to be our 3/4, so our 3/4. And then we have our plus b squared term all the way at the end, so plus b squared, which is 3/4 quantity squared. Okay, and now let's just go ahead and do our simplifications here, right? So simplifications, we see x squared, just nothing happens to it, right? 2 times x times 3/4. We remember that multiplication is both associative and commutative, right? So we can move things around, and we can multiply the 2 times the 3/4 first, right? So if we multiply 2 times 3/4, we see we're going to end up either with 6/4 or 3/2. However, if you can jump to 3/2 immediately, that's totally fine, right? So we end up with 3/2 x. And then the last thing we have to do is the 3/4 quantity squared. And if you remember when we talked about exponents applied to a fraction, that's basically saying take that exponent and apply it to the numerator as well as the denominator, right? So we would end up with a 3 squared over 4 squared, and of course 3 squared is 9, and 4 squared is 16, and oh yeah, look, that is the exact answer that we got by doing it by FOIL, right? So again, notice that this took several steps to get through. First, we had to convert it to multiplication, then we had to do the fraction multiplication, and so on and so forth, right? And then we ended up with the same answer that we got just by following the blueprint. So if you can remember the blueprints, definitely a massive time saver. Okay. Any questions with this particular question before we move forward? Helen, I don't know, is that still from earlier, or do you have a question about this? Alrighty, so I'm going to go ahead and assume we can go ahead and move forward. So moving forward, let me go ahead and clear this. So for question 69, just because I know there were a couple of people who requested it, let's go ahead and take a look at that one. So what we have is x plus y, sorry, there we go, x plus y, and this is being multiplied against x minus 2y quantity squared. Okay, so we talked like one of the very first concepts we talked about was order of operations, right? So we see we have addition, subtraction, multiplication, and exponents, right? What should come first? What should be the very first thing that we tackle as far as order of operations is concerned? Helen?
Parentheses.
Parentheses? Okay, great. You are correct. So parentheses, but we have two sets of parentheses here, right? So what's the next thing that comes down after parentheses?
Exponents.
Exponents, right? So what we see here is we have this exponent of 2 that's being applied on this x minus 2y. What I want to do is I just want to take care of that first. So by taking care of that, what I mean is we can just rewrite this as x plus y times x minus 2y and another x minus, sorry, my handwriting is getting progressively worse as the class goes on, x minus 2y. Okay, and now what we learned from the example that we did before is that because multiplication is associative, it doesn't necessarily matter which order you do this multiplication in. Either way, you're going to be taking two of these binomials and multiplying them together, and then you'll take that last binomial and multiply it against the product that you just received, right? So what I'm going to do is, because we have a blueprint for this, I'm going to take care of this x minus 2y times x minus 2y, also known as this x minus 2y squared, right? So our blueprint is a minus b quantity squared. And we know that this should always come out to be a squared minus 2ab plus b squared, right? So if a is x and b is 2y, let's go ahead and just plug in, right? So we should just have this x plus y hanging around. And I know that I should have a squared, which in this case would be x squared, minus 2ab, so that's minus 2 times a, which is x, times b, which is 2y. And then we have our plus b squared term at the end of our blueprint, right? So if I scroll up, this is the last thing we have to take care of here, this plus b squared, and that's going to be the 2y squared, right? So we have this plus 2y quantity squared. Okay, so let's clean this up a little bit. So we still have this x plus y hanging around on the outside. We can go ahead and make this x squared. And then multiplying, we see we have negative 2 times x times 2y. You multiply coefficients, right? And we can't really do much else with the variables because we don't know what x and y are. So we know that this should still be a negative. 2 times 2 is 4 times x times y. And then we have over here this b squared term, 2y quantity squared. That means take this exponent and apply it to each piece that's in the parentheses, right? So 2 squared and y squared. So this should give us a plus 4y squared. Okay, I realize I'm running out of time here. It's 11:48. Hopefully I can finish this. If I don't, feel free to stick around if you would like to. So next thing that we have to do is we have to multiply this binomial times a trinomial. We just did an example of this. What is my procedure here? What am I going to do so I can, make sure that I get all of the distributions correct? So we're going to do something with this binomial here. Somebody other than Denny. Denny's helped us out a lot today. Let's see. Ryan, can you help us out? Okay, so remember that what we're going to be doing here is we're going to take our binomial and we're going to essentially chop it up, right? So we have this x plus y. We're going to take the x and multiply it against the entire trinomial. So x squared minus 4xy plus 4y squared. And we're also going to do the same thing with the other piece of the binomial, right? So the y, so this plus y, and then also x squared minus 4xy plus 4y squared. And now when we multiply throughout, this gets pretty easy, right? X times x squared is just x cubed. X times negative 4xy, there's already an x in there, so we can just increment that power. So this is going to be negative 4x squared y. And then there was no x in this last term, so it's just plus 4x y squared. You could also write it as 4y squared x, doesn't matter. Okay. Moving on, we have y times x squared. This just, of course, gives us x squared y. We see we have y times negative 4xy, so we have minus 4xy squared. And then we have this positive y times 4y squared, and so that's just going to increment that power, so we have 4y cubed. And now the last piece of this is we're looking for matching components, right? We're looking for like terms. So we have to be really careful here because sometimes they can get a little bit tricky with the powers being on different variables. So we see there's no x cubed term anywhere else, right? So x cubed is going to live all by itself over here, not touching it. Now we have this, now we have this negative 4x squared y. So what I'm looking for is I'm looking for another term that has x squared y and y to the first power. And we see that we actually do have that one term right there. So we have negative 4 of the first time that we see it and positive 1 of the second time that we see it. So when we combine those, we should end up with a negative 3x squared y. And then again, we're doing the same thing here, right? X to the first power, y to the second power. We see that it's repeated here. So we have a positive 4xy squared, a negative 4xy squared. So these are entirely going to cancel out. And then there's no other iteration of y cubed, right? So y cubed is just going to come down. So the 4y cubed. And this here would be your final answer. Okay, I know I went a little bit over. I'm going to go ahead and end the recording here. Thank you guys. Next lecture will be up. If you guys have any questions, feel free to let me know. Office hours again today, 4:15 to 5:15. And if I'm a little late, just stick around. Okay, have a great rest of your day.